Hi everyone, it's Mrs. Mann. You're not seeing my webcam today because we need to put two things on the screen so that you can see both the handout and the simulation, so you know exactly what to do with this handout. And I would just take too much space anyway. So here's what you will see. If you look through your handout, notice how there's different colors, and those different colors go with what grade you want to try for. Now notice how I just said try for, and the reason why is because you actually have to do the simulation and go through all the questions, read them. Don't just put anything down. Don't just submit a blank handout, because I actually do read all your stuff, so and grade it. So I'm just not looking for you guys to submit and then I'm just clicking OK. So make sure you're actually putting in some effort. All right. Okay. Plus this one's fun anyway. It's a simulation and it's skateboarding. So let's see how you skateboarders use potential and kinetic energy. First thing I need to do is start with the intro box. So when I click on this link, it takes me straight to this place right here. And I'm going to click the intro box. And notice how I have like a settings area. And then I have some other ramps that I can use. I'm going to keep it here. But it says click the boxes for speed, grid, and bar graphs so you can answer the questions easier. So I'm going to click on those three boxes and notice how I get a grid. Like now I'm on a graph. There's a speed dial and then there's this bar graph over here, and notice how it says kinetic, potential, and thermal energy. Thermal energy is heat energy, and then it says total energy right here. So the first thing it says is watch the bar graph as the skater goes back and forth on the ramp. And you might want to click slow motion to be able to compare easier. So slow motion is down here. Well, let's see what happens first. So I'm going to take the skater and I'm going to put her on the top of the ramp and see what happens. And notice how my bar graph, kinetic and potential energy move. The speed's moving. What's my question? It says, what's the relationship between kinetic energy and potential energy? And if I come over here, it says when kinetic energy increases, potential energy blank. I wonder if it means increases or decreases. I don't know yet. And when potential energy increases, kinetic energy increases or decreases. I don't know yet. So let's look at the bar graph. So as she's going up and down the ramp, notice how the kinetic and potential energy bars are going up and down. So when kinetic energy is increasing, it's going up. What's happening to potential energy? Well, I can't really tell. It's going too fast, so let's go slow motion. That's so much easier to see. So when kinetic energy increases, there it's going up. Potential energy, is it increasing or decreasing? And when potential energy increases, kinetic energy is, so it's increasing and kinetic energy is going down. So go ahead and write those in. Okay, and then it's asking what happens to total energy when KE, kinetic energy, and PE, potential energy, change. So here's the total energy. Is anything happening? Is it increasing? Is it decreasing as it's going up and down? So that's what you have to tell me here. And then it says increase the girl's mass by sliding the button over to the right. So here's the slider. And I'm going to slide it over to the right and increase her mass. She just got older, taller. And so what happens to total energy? Well, you know what? I wasn't even paying attention to total energy before. So really, like where it was. So let's go back, put it back at half. And so here's where it was at half. And then I'm going to make her large again. Large. And there's where it is now. So did it increase? Did it decrease? Did it stay the same? And highlight, please, in a different color than yellow. so I can see it. And then what happens to speed when you increase her mass? Well, I wasn't even paying attention to the speed dial really, so let's go ahead and look at that. So I'm going to make it go back to half. And let's see where speed goes. Max speed is about right here. Okay, in between these two lines. Yeah, okay, so like right over here somewhere. So then I'm going to increase her mass. And does speed change at all? Let's see on this next go around. No, it pretty much is, it's right there. So that's what we do for number 4. And then for the second part, we're done with the first part now. So now for the second part, let's go to the friction choice. And that's down here in the middle box at the bottom. So I'm going to go to the middle box down here at the bottom. And that's the friction part. And then it says click on the boxes for speed, the gradient bar graph. So we're going to do that again. And then watch the bar as the skater goes back and forth on the ramp. So we're going to do the same thing and put it on the ramp. And then notice how, oh, what thermal energy is going on? What's going on with that? So, and she's slowing down. So let's find out. Number 5 says what happens to speed when you add friction. So friction is in the middle. I wonder what happens if I do nothing. And then I look over here. Oh, that looks like before. Well, what if I put it all the way over? Okay, what if I put it back? What if I put it over here? And so I'm looking at both speed and what she's doing and looking over here at the bars as I'm moving this back and forth. So you have to compare. And then it says which type of energy decreases when you add friction. So you have to come over here and check that out when you add friction. And then if she stops, go ahead and put her back up. So she keeps going while you're studying that. And then what is the relationship between friction and thermal energy? So then you have to look at thermal energy. If you decide to go to part 3, you're going to go to the playground. And so the playground is down here, bottom right. And so what you're going to do at the playground is you're going to click and drag the ramp sections to where you want them to go to make your ramp that she's going to skate. So first, let's go to the boxes. Check the boxes, speed, grid, and bar graph, right? Just like the before. But then I'm going to make a ramp. So I'm going to use these sections right here to make a ramp. And these red dots are your anchor points and your connection points. So if I want to make a ramp, I can connect these so she doesn't just fall off. Okay, so you have to make a loop. That's one of the things, because if you notice down here, it says as you go through a loop, the most potential energy is and the most kinetic energy. So remember, you can use slow motion to find out what this is doing over here in the bar graph. But you want to make a ramp for your skater. And you want to make the first part has to be pretty tall. Okay, and then you can just keep connecting. But you only have 5 sections. So make sure you're doing what you need to do, right? You need a hill, you need a loop. So here's my ramp. Try and get her to go through a loop. And then you're going to take a screenshot and you're going to post that in the discussion. The other thing you're going to do is, if you decide to do the conclusion, is and go for the A. These are just questions. They're just a summary of what you did already. You're checking the correct one and highlighting down here. And then there's a Tony Hawk video. And Tony Hawk is a really famous skater. He was probably the first person who put skating like as a professional sport. So, and he's doing a vertical loop. in this video. It's actually pretty cool. So you're watching the video and answering these questions. And then for the A++, so there's like a little bit of extra credit, like 5 points of extra credit. You can try these questions here for this claim. Tony Hawk uses changes and energy to make it through the vertical loop. So what's the evidence for that? What did you see, right? How do you know energy changed? So that's going to be your evidence. And the reasoning goes here. Explain how energy changes and how it relates to speed as he's going down the vertical loop. And so you should be able to answer that question if you've done everything else. All right. And then you're going to submit this handout, and then we'll see you later.